This is Science Friday. I'm Ira Flato. When you think about Albert Einstein, the words E equals mc squared and theory of relativity naturally come to mind. But Einstein did not win his Nobel Prize for that work. Instead, he won the prize for figuring out how light interacts with objects and for believing, when almost no one else did, that light and energy are carried as discrete packets called quanta. He was a pioneer in quantum mechanics and the first to champion the idea that light can behave as a particle and as a wave. All this is laid out beautifully in a new book called Einstein and the Quantum, The Quest of the Valiant Swabian. And don't worry, we'll talk about what that last word means. Joining us now is Doug Stone. He's author of Einstein and the Quantum. Dr. Stone is a theoretical physicist at Yale and professor of physics and applied physics there. Welcome to Science Friday, Dr. Stone.
It's great to be here, Ira.
Where does the name Valiant Swabian come from?
Yeah, well, so when I set out to do this book, I decided I would have to read through all the letters of the time and obviously a lot of the biographical material to try to make it, put it in context and get a sense of what Einstein was like, particularly the young Einstein. And one of the things I discovered is that he was really quite a funny guy. And just had a lot of joie de vivre. And one of the things that he picked up was being from the German region of Swabia and known for having that accent and so on. There was a famous poem called The Valiant Swabian, written by a romantic poet, Ludwig Uhland. And it's about this crusader knight who triumphs against the Saracens through adversity. And when he was just getting out of his college degree and having some challenges, he just started to refer to himself with his girlfriend and then wife as the Valiant Swabian. He would sign his letters that way. And it's sort of like somebody today signing their email, Indiana Jones or something. It was just a kind of humorous little nickname that he adopted.
And he kept using it throughout his youth there.
No, I mean, through his youth. I didn't find it in his later letters, but during that early period from about age 20 to 25, he had all sorts of funny nicknames, and there was just a lot of almost ribald humor in his letters.
Well, it's a fascinating book. It's a great read, and it's fascinating to learn about him being a champion of quantum mechanics. And you open your book talking about Max Planck at a meeting at the German Physical Society in 1900. And one of the talks before his essentially disproved the theory Planck had been working on for the last 5 years. So in a moment of desperation, Planck invents this huge fudge factor called quantum theory, which you say is sort of the moment that opened the door for Einstein.
Yes, very much. And the reason it opened the door for Einstein was because Planck himself was a very conservative guy. And basically he was trying to save his reputation. Because as a theorist, our reputation is that, when we claim something follows deductively from the laws of nature, that we're right. If we're wrong, we're just bad theorists. We're bad technicians. So he had actually claimed this just the year before about a description of the radiation that comes from hot objects, which we call black body radiation. And he had picked the wrong law. He had deduced the wrong law, and he said it was absolutely correct. And then just before him, this physicist showed data that showed that definitely his choice for the law was wrong. So he was kind of casting about, trying to find up an alternative law. He first just guessed a sort of interpolation formula to fit the data. And then a few months later, he introduced this big kind of kludge or fudge factor having to do with quantization of energy, which got the answer that he had guessed, but kind of didn't fit in with any of the other physics of the time. So
no one else was believing in that idea.
Right. And he basically then buried it because it was such a crazy idea that he didn't want to insist that he'd actually discovered this new law of nature. I mean, buried it meaning he didn't write anything about it for 5 years. He didn't defend it, nothing. And Einstein came along pondering this and pondering light. As you mentioned, he got his Nobel Prize for what he did in 1905, one of the things, along with relativity. And the other thing, one of the other things that was so fabulous was suggesting light could be a particle. And in that paper, he was clearly pondering Planck's formula in a very deep way. And he, unlike Planck, was willing to embrace the fact that this means there are whole new laws of nature for atoms and for light.
And he didn't have much, he talks about it, and you write in your book, his conviction that wave and particle properties of light coexist, and a new electrical and mechanical theory would provide a synthesis of these old categories. At this time, Einstein was the only scientist on the planet to perceive this need. And as you write, you say this took precedence over even thinking about relativity for him at that time.
Yeah, so this was one of the reasons I wanted to write the book, and the thing that surprised me when I started to do the research, that a lot of the popular story is Einstein does special relativity in 1905. He starts general relativity in 1907, finishes it in 1915, and the rest is history, and unified field theory, which he never got. Well, actually, most of that time, he was much more focused on light and its interaction with atoms. And, in 1909, he writes to his friend, this quantum problem is so important, why isn't everyone working on it? And everybody wasn't, because he was the only one that understood that this was the big kahuna. This was the big problem for the future of physics, that we couldn't describe atoms with the familiar laws that we thought applied.
Meanwhile, he's virtually making no money. He has no position at a university. He's working in the patent office, right? And he's after a while, he's starting to correspond with some of the great luminaries. I mean, the big names, but he's never met any of them.
Yeah, so there's even this story that Max Planck didn't actually go to the patent office to meet Einstein, but he sent his assistant, Max von Laue, who again became very famous later. And apparently von Laue just walked right by Einstein because he couldn't believe this was the same guy, So, but anyway, yes, he was working 6 days a week, 10 hours a day, had almost no vacation, and he couldn't meet any of the guys. They didn't come to Bern, Switzerland. So, but of course, when his papers started appearing, they realized there was this sort of mysterious genius. How could this be? So it wasn't really till 1909 that anybody even met him, and he ever met any of the famous theoretical physicists in the world, 4 years after many of its breakthroughs.
So when did people first start taking him seriously? It was not about his light theory. It was about relativity first, was it not?
Exactly. And that's the irony, because people talk about how revolutionary relativity was, which it was, and how hard it was for people to grasp. But actually, the top people immediately said, "This is a stroke of genius." Incredibly impressed. And the main person that I talk about quite a bit is Max Planck, who got so excited that he immediately gave a public lecture about it in 1905 before anyone would even listen to Einstein. Einstein had no forum to speak, but Herr Professor Planck did. So he gave the first lecture. He gave Einstein all the credit, of course. And then he worked on this theory. And this is the basis on which he and Lorentz and many of the other people started to say, well, there's a new young genius in theoretical physics.
Yeah. Well, Max Planck was the big kahuna of the day at that time, right? If he talked about you were important.
Yes, he was the leader of theoretical physics in Germany, and the other person, Hendrik Lorentz, was actually the greatest intellect that Einstein ever met, according to Einstein. So they were the two kind of admired senior figures of the day.
So now that the scientists are talking about Einstein for relativity, do they pay any more attention to him about what Einstein's really interested in, as you say, is about light and quanta?
Yeah. So basically, they try to talk him out of it. So I report the letters that have survived, in which Max Planck says, no, you're going too far, saying that light might actually be a particle. The wave picture has to be exactly correct, at least in vacuum. And Lorentz sending him long letters explaining why the wave picture was contradictory. And, they just thought he had gone too far. And it even went to the point that when Planck eventually recruited Einstein away from Switzerland to join him in Berlin in 1913, and he compares him to Galileo and the greatest scientist of all time, he says, well, there is this one little peccadillo. He proposed this particle theory of light, which really, you have to excuse him for that, And they did, but obviously it turns out he was completely right. It just took another 20 years to prove it, so.
Mm-hmm. And what's really interesting about the book, and and things you don't read in other physics books is, first of all, is how you write in the vernacular of our time, and you write in very easy to understand language. And I was impressed when you could throw in the word "forget about it" into a physics book. But you also give us an idea of the culture of the time and the personality of all those physicists, which we never get to read anywhere. I mean, it was really a close-knit group of guys, wasn't it?
Yeah, I mean, that was nice, and that's probably one of the reasons why a relative unknown could actually emerge, because they really were truth seekers. They were, admirable people. Obviously, not all of them. Some of the people Einstein corresponded with end up, becoming supporters of the Nazis, and there were big divisions later. But basically, it was a group, an elite group that admired, new truths, and they corresponded with great respect. And I actually find very little competitiveness in the letters. It's mostly extremely collegial.
There's one interesting character, one especially character, Johannes Stark, who's one of Einstein's early champions, but who later turned against him during the Nazi era.
Yeah. So Stark, it turns out, actually offered Einstein the first academic job that he was ever offered. But he was at the patent office, and the Stark's job was not good enough to get him away. It didn't pay anything. And then for a while, he was sort of Einstein's partner, because they were the two people who were really saying there are quanta of light between, say, 1905 and 1911. But he also was a very jealous guy, and I actually have a little quote that I just put in a footnote where Einstein writes to a friend and says, whenever Stark gets in an argument, he ends up with unmitigated rubbish. So I think Stark didn't feel very admired by Einstein, and that maybe had contributed to his anti-Semitism later.
All right, we're going to take a break. The book is Einstein and the Quantum, The Quest of the Valiant Swabian. We'll be right back after this break talking with Dr. Douglas Stone. Stay with us. I'm Ira Flato. This is Science Friday, talking with Dr. Douglas Stone about his book Einstein and the Quantum, The Quest of the Valiant Swabian, talking about how Einstein's real accomplishment, we all know about his theories of relativity equals mc squared, was really believing in the quantum mechanics first, before anybody really did. So what happened later on, Doug, that he would disown this whole idea? Or did he not disown this whole idea? Is that a myth also?
Well, the thing that he said over and over again, and he never disowned, or that he never changed, rather, was that quantum mechanics is only part of the truth. So the history is more or less that between 1900 or 1905 and 1925, there was just all this creative turmoil in the field, which I describe in my book. It's really fun to describe. And confusion, and Einstein at each stage actually unconfuses people and introduces new concepts which become pillars of quantum mechanics. And I won't try to review them, but it's quite a few. I say it adds up to something like 4 Nobel Prizes worth of new concepts.
Yeah.
Okay. But then in 1925, Heisenberg and then Schrödinger come up with essentially equivalent theories where certain things about quantum mechanics that Einstein can't accept are enshrined in the theory. And that those things are the uncertainty, the sort of intrinsic randomness of quantum theory, and also the fact that there's sort of an observer that seems to enter the theory as if the theory has some subjective component, and Einstein couldn't accept that. So for a few years, he actually thought maybe he could just prove the theory was contradictory. He failed at that. But then by about 1930, he says, yes, I agree, there's no contradiction. This is a part of the truth. He nominated these guys, Heisenberg and Schrödinger, for the Nobel Prize. So he clearly believed that it was a great thing they had done. But then he said, I'm looking for the rest of the truth.
Is that because of his intuitive abilities? That's how he saw things, right? He had mental pictures in his mind. He thought through problems. Is that what his intuition was telling him?
I would actually say a little different. I would put it a little differently. Because he really went away from intuition in his rejection of quantum mechanics. Early on in most of those 20 years between 1905 and 1925, he really paid attention to experiment, and he really, he didn't decide what things should be in advance. He tried to figure out what nature was telling him. And then afterwards, he went for the unified field theory and beautiful mathematics, and he sort of felt less willing to just listen to what nature was telling him. So, as I argue in the book, I think it was his philosophical beliefs about why he was doing science and why it was a noble pursuit, sort of the justification of his life's mission, which was to find these objective truths about the world that were independent of man, eternal truths. And because quantum mechanics seemed to involve an observer, he really didn't like that framework. And he used to say in this just shorthand, do you really believe that the moon isn't there when you're not looking at it?
Yeah. If he had lived long enough to see how successful quantum theory is today, do you think he might have changed his mind about it?
That's one of the greatest questions if you want to go back through a wormhole, since, relativity and so on suggest there could be such things, although I don't think it's very realistic. Asking him in the light of what we know today would be fascinating, because now we finally have really good experiments which address some of the weird things in quantum mechanics which he felt just couldn't be true. But not only are they true, but we have, very, very clear experimental evidence that they're true. And so it would be interesting to see if that would move him one iota from his conviction.
Yeah. Doug Stone, I want to thank you for taking time to be with us today. It's a fascinating book, so well written. Lay people can easily understand this. It's full of science, personality, and the history of science, what was going on 120 years ago. Thank you for taking time to be with us today.
Oh,
Doug
it was a great
Stone,
pleasure. Thank you.
You're welcome. Author of Einstein and the Quantum. He's a theoretical physicist at Yale University, professor of physics and applied scientist there.